Today, we're going to zoom in on one of the key aspects of the application process. In fact, I would go so far as to say this is the most important step of the application process, and that is surface preparation. And to discuss the importance of surface preparation and to highlight some of the scary pitfalls or gremlins, I'm delighted to be welcoming Gert Conradie back to the microphone.
We can now say that the paperwork is done. We've spoken about documentations and specifications, and as you said, the most important step now follows, and that's surface preparation.
Now, I know that you undertake coating failure investigations, and I'm sure you've got a whole bunch of wonderful stories, but can you give us an idea of what you've experienced the ratio of failures due to surface preparation compared with other failures from your own experience?
Sure. You know, when we talk about coating gremlins, some of those coating failures look like gremlins on the surface. And actually, there has been a study done worldwide, and they have accurately pinned it down that 80 to 90% of failures on coatings that occur are because of inadequate or improper surface preparation that took place. So definitely a high number and very important.
That's a terrifying thought, because it's not difficult, and I'm not saying it's not challenging, but it's not difficult to follow the rules and to do it right. So let's look at surface preparation and briefly discuss what do we actually include under this banner of surface preparation.
Well, let's talk about some of those failures that occur. And I think a lot of the failures that happen is because of people leaving residual mill scale on the surface. That's not the only thing that's left on the surface. We're talking about new steel now. You've got the mill scale, but you've also got contaminants that you can see and contaminants that you can't see, visible and non-visible contaminants. So you've got your chlorides, you've got your sulfates, you've got your nitrates, you've got oil, grease, and other dust particles that left on the surface. And if these are not removed, you're definitely lining yourself up for a failure. Besides that, during the manufacturing process, we know what happens is they don't just bond these two items together with glue. In some cases they do, but most of the time they actually weld these items or rivet them together. And now you're sitting with another additional thing that you need to look at, which is weld splatter, or rough welds and sharp corners and so forth. I think that gets overlooked quite a lot. People reuse blasting grit. They think, you know, the cheap way is the easy way, so they blast it and, let's just put it through a sieve and reuse it again. And what they don't realize is what they've just blasted off in contaminants, they're just putting back onto the surface.
Let's just roll back. I would imagine the first step we should look at is the repairing or cleaning of our welds. So let's just spend a little bit of time looking at weld repair and cleaning.
I think a lot of contractors unfortunately overlook the aspect of this portion of the specification. When they read through the specification, they see the standard 8501-1 and they sort of like blinded or focused mainly on how do I blast the surface clean? Is it a SA2? Is it a SA3? Is it a SA2.5? And they overlook the importance of the ST2 and the ST3, which is hand and power tool cleaning. The reason behind them doing this is unfortunately that they think that sandblasting or grit blasting will remove these weld defects. It will soften the corners, but nothing can be further from the truth. Unfortunately, the pre-preparation means that they have to use hand tools and power tools in order to address, or should I say, dress the actual corners and sharp edges and welds before they put anything on. What happens is when they do it, they actually do it in an incorrect way. So if you've got a sharp corner and they run a grinder over that actual edge, by doing that, they've taken one sharp corner and they've made it into two sharp corners. Instead of radiusing or rounding the corner. So again, just going back to our previous discussion, it's so important to understand when we talk about hand and power tool, how we're going to achieve rounded corners and remove the weld splatter.
We've spoken about welding, and sometimes the welding can be very poor and leaves a dramatic mess. And you're absolutely right. If you don't take it off, I'm sure we've all seen examples where someone has tried gallantly actually to paint over it, and that's really inadequate. So cleaning up the welds, I guess, often overlooked, but really key to, as you say, pre-prepare the surface. And when we get to the surface cleanliness, the SA3, SA2.5 standard, surface cleanliness is a bit of a hot potato, I think. So let's talk about actually, now that we've prepared the surface, now actually cleaning the surface, what sequence should we be using to get rid of dirt, grease, blast cleaning, and why do we choose the sequence we choose?
Mainly it is to conform to the actual standard. When you look at any of these standards, the terminology used in the standard starts off by saying, when viewed without magnification, the surface shall be free of all visible oil, grease, dust, dirt, mill scale, and so forth, depending on what cleanliness standard you want to achieve. So by doing that, you can't just take a blast nozzle and try and remove all of that. You'll have to look at a way of removing the oil. And bear in mind, talking about welds, what a lot of the manufacturers will do to prevent weld splatter from sticking to their surface is actually using a silicone spray and spraying it next to the areas that they weld, so that when they have these droplets depositing, it doesn't stick to the steel. But now you're sitting with that on your surface and they go and blast it thinking, oh, okay, we've removed it all. But in essence, what they've done, they've taken that silicone spray, which is an excellent mold release, and they've driven it deeper into the actual profile, and it's very difficult then to try and remove it. So by high pressure cleaning or using a solvent with soapy water or a biodegradable detergent, that's the proper way to wash the surface before any blasting exercise takes place.
I guess the analogy in the kitchen would be, if you're using a decent dishwashing liquid, you're going to remove the grease and the oil. And that's really what we want to do to the surface of our steel. Now, we all are familiar, I think, with the cleanliness standards such as SA 2.5 and SA 3. How can we define those? And firstly, what exactly do they mean? And secondly, why are these standards so often a gremlin from your experience?
Well, when we look at the 8501-1 standard, as I've mentioned, when you read through the methodology, it states that when viewed without magnification, the surface shall be free of visible oil, grease, dust, dirt, mill scale. And then it allows certain degrees of shading that is left on the surface. Now, a lot of people, unfortunately, they don't understand when they look at shading how it differs from the actual mill scale or dirt that's on the surface. So it's very important that when a level of cleanliness gets defined, that the mill scale gets removed. That's one of the main things. If it's just in a quick prefabrication and they want to get the surface clean before welding it, so that they don't include mill scale in part of their weld, which can cause inclusions in your welding, they would then give it a little surface blast called an SA1 or a SA2, where you are allowed small traces of that to actually remain. But the gremlin that really comes in is that it says when viewed without magnification. It's not measurable. The way I look at it versus the way you look at it versus the way a different engineer might look at it, he might say, well, I'm happy with this cleanliness, it conforms. And that's where the gremlin starts creeping in.
I'm sure also it's a good idea to know what sort of steel you're starting with. Is this new steel straight from the mill, or if this is like really old rusted stuff that's been sitting in someone's backyard for years?
Correct. The Swedish standard actually starts off by defining what the different type of surfaces should look like prior to blasting. And if you look at the definitions, a rust grade A steel is steel that's completely covered with mill scale, with no rust or a little bit of rust if there's anything. Rust grade B, you could say, is like a 50-50. There's a little bit of mill scale that's residual on the surface with a little bit of rust that's occurred. And typically grade A and grade B would refer to new steel, straight out of the mill, or rust grade B steel that might have been sitting in a yard or inside a workshop for about a year or so. And then you can see a little bit of rust occurring. But when we step over to evaluating the surface and saying it's a rust grade C or a rust grade D, this is now either previously coated steel or pre-manufactured blasted steel. So rust grade C talks about completely with rust, but no mill scale on the surface because it's all flaked off, but there's no pitting or very, very small pitting that occurs. And in rust grade D will then refer to a steel surface when looking at it that is rusted completely, and you're starting to see these anodic pits that has formed over the surface that are relatively deep, almost like a orange peel effect over the entire surface. So evaluating that surface and understanding what we're looking at before we blast, we'll be able to determine how are we going to achieve it. Now, you won't get A grade steel blasted to an SA2 or a SA3 because you're not allowed any mill scale on it. So both A and B won't be specified in certain instances, but now you go to a C and a B grade, now you can actually achieve what the standard then refers to.
But now when we want to see what is an SA 2.5 or an SA 3, that is sort of that bright, shiny steel after we've done the blasting.
That's right. And again, this is where a lot of people now misinterpret certain standards. When we look again, and there's a photograph that you can share with us, which is the Swedish standard, the ISO 8501-1 standard, which talks about the different grades of blasting. So an SA1 and an SA2 and an SA2.5 and an SA3, when we talk of the terminology used, SA3 is visually clean steel. SA2.5 is very thorough blasted steel. SA2 is thoroughly blasted steel, and SA1 is light blasted steel. Now, a lot of people look at this and they know of NACE, or they've heard of NACE, and they say, oh, you know what, SA3 is white metal, or SA2.5 is near white metal. But the terminologies differ. And remember, I spoke about it being measurable. The SA standards used in ISO 8501-1 are visual standards. So you've got a pictorial guide that guides you through in order to assess your surface. Whereas when you go to the NACE standards, they are written standards. And the written standards are now measurable over a surface area. Typically, they mention in a standard of about 3 inches by 3 inches, where you can say you allowed a certain percentage of staining that is allowed, or mill scale that is allowed to remain on the surface. Just looking at that picture, if you see SA1 and 2, there's actually mill scale that's left on that surface.
So taking these pictures to site is the way to evaluate the cleanliness of the surface.
Most definitely, that is one way. But another way that the inspector or engineer can get out of this debate is by asking for a coupon or a blasted panel prior to the project starting, so that everybody agrees around the table, listen guys, here's my little panel, I've blasted it to SA2.5, does everybody agree with me? This is what we're going to have on the project. Then you can even put a little bit of a laminate on it, or you put it inside a plastic folder, and you use that coupon as you go through your project in order for you to evaluate the surface to say, yes, does it conform or does it not conform? So you reach that consensus before the project starts.
So we can really only achieve those standards with blast cleaning. We're not going to get to an SA2.5 or an SA3 if we're trying to use power tools. Am I correct?
Most definitely. And if you remember that picture that you showed of the rust grades, imagine taking a power wire brush or a grinder and trying to remove mill scale off a surface. When you use a power wire brush in order to try and remove your well splatter or whatever it is that's next to it, it's only going to give you a polished surface. That polished surface might look like it's a clean surface, but you've actually given a smooth mirror type finish. And if you put anything on top of it, it's just going to fail. And if you leave any residual oils or thing on top of the surface, all it's going to do is going to spread it. And that's why, again, it's so important to do that pre-cleaning before starting any of your power tool or abrasive blasting activities.
So now we've got our abraded surface. It's clean, it's shiny. Obviously, we don't want to get fingerprints on it even, because that's introducing another form of grease. But we spoke about non-visible contaminants. So now many people are from the view of, you know, what you can't see, you don't worry about. But there are contaminants that we do need to worry about. Let's have a brief chat about some of those.
Our non-visible contaminants are your chlorides, sulfates and nitrates, which are only some of those non-visible contaminants that might be left on top of the surface. And we say non-visible because visually to the eye, you cannot see that they are there. So how do you test for them? And again, now in your specification and in your documentation, you will require them to do a Bresley patch test or a sleeve test, or maybe you just use, in South Africa, we talk about Weber-Riley tests, or we talk about Wattman paper, which is a little paper that you place on top of the surface, and using distilled water will tell you whether there are salts. And again, your specification will then refer you back to what is the allowed tolerances that you are allowed on the surface before putting a coating on. You see, the problem is if you don't take it off, Salts, they've got a high affinity for moisture. Unfortunately, this relationship is destined for failure. The salt makes the coating pregnant, if I can put it that way. So it will cause blisters and bubbles to develop underneath the coating, which is something that you don't want. And again, you don't see it until after you've put the coating on. And then you see these pregnant coatings appearing everywhere, bubbles and blisters everywhere.
That's such a sweet analogy. And I'm going to look at blisters on coating with different eyes from here on. Thank you for that picture, Gert. I was also just thinking one of the things, and probably before we do the salt testing, is the dust. Having spent not many hours, but several days in a blast yard, the dust levels are unbelievable. So one thinks that the surface is clean, and visually the steel is clean, but it's also very dusty. And dust can also be hygroscopic, actually, and absorb water, and also just prevent adhesion, because the paint will stick to the dust and not to the steel, and then fall off the steel itself. So making sure we've got no dust is also something that it's easy to overlook, and very definitely needs to be a line item in your QCP so that you are reminded to double check.
Most definitely. And the only way that you can effectively remove it is by using a vacuum cleaner. A lot of people actually, they do use the method of blasting it off with clean air, but now you get into the debate of what is clean air. You know, how clean is my air? Because your air could be contaminated with oil or water, and you can actually now be contaminating your surface all over again. And a lot of the blast yards that you mentioned, they're in the open. They're out there in the open. So what's part of your soil that's outside? You've got salts, and you've got all other contaminants that's in there. And as you've mentioned, these are all hygroscopic. So they've got a high affinity for water. They're going to draw water through the coating by means of osmosis and actually cause an osmotic blister to occur beneath the coating.
I think as we sort of close off the surface preparation discussion today, we have assumed that we started our blasting process with, shall we say, gremlin-free, very robust documentation. And we now want to make sure that what we've stated in our documentation is in fact implemented. What do you think are some ways that we can ensure that we kind of get what we want?
I like to always tell people that the two most important things that we were all gifted with, and some of that have a higher ability than what others do, but it's our eyes. What we're able to see on site is so important. A visual representation of what you're getting at the project. When you arrive on site and you see dust on the surface, when you see moisture deposits on your boots as you're busy walking, so you cannot leave out the fact that a good quality control is essential to have for the contract. Someone watching over the process, double checking that they're following the actual written specification, the quality, the QCP, and then using the quality control plan and the product data sheets and the QCP. A good inspector or a good QC will draw up something for him that's called an ITP, an inspection test plan. So with this inspection test plan, he can itemize each line item and say, if I'm blasting, what standard am I going to do it to? What will be my acceptance and rejection criteria? And where can I find it in the documentation? So it's a quick reference for him to go back. And again, then just using that documentation when going to site. And when it comes to the asset owners and engineers, we highly recommend that they use an independent third-party inspector. You see, unfortunately, contractors trust their workers and they see that nothing that they do is wrong. But when you've got an outside view, they can quickly pick up things that you overlook every day because you don't see it. So it's very important that a third-party coating inspector that's not paid by the contractor gets used for the actual inspection work.
Very often when we do something repeatedly, we don't see what we do. I'm sure many of us have had the example of where you've driven from home to the office, you've got to the office and you get, how did I get here? We kind of do it on autopilot. And I think you're right, Gert. I think we expect the blaster, the well dresser, the surface cleaning person to do their jobs. And while they may intend to do their jobs well, they've perhaps got some little bad habit, or they had a bad night last night and they just forgot. And having that outside, as you say, that extra pair of eyes who stands independently and who is fair. I think that's really important, is that a third-party inspector really needs to be fair in the way they apply the terms of the specification and so on. But if they're pointing out, we didn't take the temperature this morning, you haven't recorded the profile of this particular sample or whatever, just to ensure that each step is followed with the appropriate frequency. And all of those gremlins would have been ironed out in that pre-conference where those definitions are set. So we're going to do it once a day, we're going to do it every pipe, whatever the requirement is for that particular project.
And when you were talking about the coating failures, I mean, when we say that 80 or 90% of failures that occur, is related to the poor surface preparation. With failure investigations that I've conducted myself and that various others independent inspectors have, you always come down to that point where you realize that had a third-party inspector been there on the original project, they could have prevented a lot of this from happening. So you go in there, you see, but they didn't blast the surface properly. They didn't remove the oil and the grease. They didn't test for salts. And now you're sitting with rework that you've got to do, as we've mentioned, that can be very expensive. And again, that's the situation you want to try and avoid.